Hi, in this video we're going to learn how to construct a scatter plot and use the mean point method in order to draw the line of best fit. Okay, so let's say I have some data here. In this chart I have some data that represents the hours of work and the number of tasks completed. Okay, so the hours that I spend at work is what I'm calculating, and the number of tasks completed. So the hours of work is on the x-axis. So that's the hours, and then this is the number of tasks. So that's the task, and that's going to represent the y-axis. So let's say I have the numbers, let's say 1, let's say 4, let's say 8, let's say 5, let's say 7, and let's say 4 again. All right, so what I have here is a scatter. I'm going to make a scatter plot to track this data so that I can see the relationship between the number of hours at work, I should say at work, and the number of tasks that get completed. Okay, so it's not talking about how long the task is, it's just tracking the number of tasks. All right, so if I'm at work for 1 hour, so 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And then this is the number of tasks completed, and I'm going to count in 2 so that I'll have enough room on my graph. 2, 4, 6, 8, and 10. All right, and you know what? I'm going to change this last number down here to 9. Okay. All right, so what we can see is that if I'm at work for 1 hour, I complete 2 tasks. At work for 2 hours, I complete 4 tasks, and this one should actually be here. And if I'm at work for 3 hours, I complete 8 tasks. At work for 4 hours, on this day I completed, for 4 hours I complete 5 tasks, so that would be here. And at work for 5 hours, 7 tasks, so that would be here. And then at work for 6 hours, 9 tasks. All right, so we can see a general relationship in our scatter plot. So it's called a scatter, obviously. It's a scatter because it's not a perfect line. Our points are scattered. They don't all form a line. Okay, so we can look at this one and we can see that this type of scatter, I would say that it's a positive correlation. And I would also say that the strength, this one, it seems like we don't have very many point strength from the data. Most of our points are lined up, so I would actually call this a strong correlation. Okay, so the type is positive and the strength is strong. All right, so now let's figure out how to do our line of best fit. Well, we want an accurate line of best fit. So in order to draw a line of best fit, what I need to do is I need to find the middle, or the average data. Okay, so what I need to do is I'm going to calculate all the x's and find the average, and then I'm going to calculate all the y's and find the average so that I can find the mean point. Okay, so if I add up all of my x's, go ahead and do that for a minute. The sum of x divided by the total number of x's, and then that will give me x bar. And then the same thing for y, the sum of all the y's divided by the total number, that will give me y bar. So the point that I'm going to get, x bar comma y bar, is actually what we call the mean point. So that's the average point of all of my data. So since I have 2 variables, it's a mean point and not just the mean. It's the mean of the x's and the mean of the y's, because I'm looking at 2 relationships at the same time and comparing those 2 relationships. Okay, so pause the video and go ahead and calculate the mean point. Okay, so in my calculation, I got that x bar is 3.5 and I got that y bar is 5.8. So the mean point would be 3.5 comma 5.8, and I round it to the nearest tenth, which is fine for what we're doing. We don't need too much accuracy, and our numbers are not going to be exact because we're actually finding the average of the numbers, and so we may not be dividing the numbers by an even number that will give us a whole number. Okay, so what I'm going to do is I'm going to take this mean point, I'm going to plot it. So I'm going to go to my graph and plot 3.5, 5.8. 3.5 is here, 5.8, 5 will be about right here. Actually, no, that's not right. 5 will be about here, and 5.8 would be pretty close to 6, so I would say I'm going to put it about there. Okay, so this is the mean point, and that is the point 3.5 comma 5.8. That's the mean point. It wasn't included in your data, right? It's a separate point, but it's just telling you where the center of all of your points are. Okay. All right, so I'm looking at the average point, and so what I'm going to do is I'm going to pick another line in the path of my center, and I want to draw a trend line so that I have approximately an even amount of number of points on each side. So I have 1, 2, 3, 4, 5, 6 points, not counting my mean point. And so I'm going to pick another point. Let's say maybe I could pick this point here, Okay, and you could have picked this point or this point. It doesn't really matter, but your goal, the best point, obviously will have approximately the same amount of data points on each side. So when I draw my mean point, when I draw my line through my mean point and my center, through the second point and the mean point, then I may hit another point, and that's okay, because I could have used either of these. I could have used this point or this point. So I'm going to use the easy one. I'm going to take the easy road. So I'm going to use 2, 4. Okay, if you use this point, it'll be 5, I think it was 5, 7. Okay, so, or approximately 7, as close as we can get it. All right, so if you use that point, that's fine. You'll get a similar answer, but it won't be exact. Okay, so what I need to do now is I'm going to come over and I need to find the equation of this line of best fit. So the equation is going to be in the form y equals mx plus b, because I can see that my correlation is linear and it forms a positive linear correlation. And so as one variable increases, the other increases, and so we know that it's going to look like a line. Okay, all right, so let's calculate the mean point. So I have two methods that I can use, but first we have to, in order to calculate the equation, I need a slope. So remember that I'm using these 2 points here. So in order to calculate my slope, let me go ahead and write my 2 points, 3.5 comma 5.8, and then the second point is 2, 4. So I'm going to use y2 minus y1 over x2 minus x1 in order to get the slope of the line, as we always do when we have 2 points. So that's going to be 4 minus 5.8 and 2 minus 3.5. Okay, so go ahead and calculate what that slope is. So pause the video and calculate the slope. Okay, so you should have gotten 1.2. That's what I got in when I did the calculation. If you didn't get that, go back and check it. Okay, so now what we're going to do is we're going to write the equation of the line. So I can use y equals mx plus b. So this is option A, and I'll show you how to do option B also. So what I'm going to do is I'm going to pick a point to plug in. Always pick a point from your data set, because that's going to be the most accurate, especially if you miscalculated your mean. Okay, so I'm going to use 2, 4, and I'm going to plug those in. So 4 goes into y, and 2 goes into x, and then I'm going to plug in that slope that I just found, that slope of 1.2. Okay, so 4 is equal to 1.2 times 2 plus b, and so let's calculate that. 1.2 times 2, that will give me 2.4 plus b is equal to 4. So now let's just move this 2.4 to the other side. All right, so 4 minus 2.4, that will give me b is equal to 1.6. So if I were to write the equation of my line, y is equal to, the slope was 1.2, so 1.2x plus 1.6. So there is the equation of my line in the form y equals mx plus b. So what I can do is I can use this line to actually predict anything. So let's say that I want to know if I work 10 hours, approximately how many tasks can I get done? So y is equal to 1.2 times 10 plus 1.6. I'm going to go ahead and tally that up. That would be what? 12 plus 1.6. That would be about 13.6 tasks. Okay, so that's how you can use your equation to make predictions in the future. I could also use this equation to say, okay, well, if I complete 20 tasks, then how many hours did I work? Well, if that case, if I completed 20 tasks, since task is my y, then I would say 20 is equal to 1.2x plus 1.6, right? So now I'm going to solve for x. Well, I'm going to move 1.6 to the other side, minus 1.6, and so 20 minus 1.6 is equal to 18.4, and all that's equal to 1.2x, and then divide by 1.2, divide by 1.2, and so x is equal to 18.4 divided by 1.2. That gives me about 15.33, so about 15.3 hours. Okay, so that would be the answer to that particular question, and that's based on my trend line. It doesn't mean that that exactly has to happen, but if this trend continues and I completed 20 tasks, and you can assume or predict that I must have worked 15.33 hours based on the trend that we have. So basically what a scatter plot is and finding a trend line is using past data to predict what's going to happen in the future. Okay, you don't know, there's no guarantee, but it's the best prediction that we can make based on the data points that we have. Okay, I hope this video has helped you, and I will see you in the next video.